All right. So there are different ways you could approach this. And let me just show you two ways. And I'm only going to solve it one way, but I just want to show you. You could, and now if I think of this as 0.5, I'm not writing yet. No, okay, sorry. If I write this as 0.5, it might make it the math work out a little, and that'll be 2.5. Just a little bit easier to see it that way. So we could think of this in terms of proportions. There's 0.5, which represents 18 miles. So therefore, 2.5 will equal X number of miles. And so you could go through and do your cross products, and we are going to be working a lot with proportions. So if you want to think of it that way, you can. Now, the other way that you might think about it, I'll just erase all this. So you might have, my internet connection is going slow. Oh, sorry, I hit the wrong button. That's why. Sorry. So if this is 0.5 inches, and that represents 18 miles, well, then you can imagine if you had 2.5 inches. All right, so here's 0.5 over and over. It'll just take me a second to write this. So if it helps you visually to kind of write it out this way for a problem like this, now total, this represents 2.5, and we can add that up, we can see it, but each one of these represents 18 miles. So then I could just figure out if I've got 2.5 inches on the map, then I can just add these up, 18 plus 18 plus 18. Regardless of the way that you solve this, you will get 90 as your answer. And that's what the most popular answer was today. So lots of different ways of looking at this problem, and hopefully that makes sense for all of you. All right, so today we're going to learn the last little bit that we need. And so we already learned about midpoint formula. We learned about perpendicular lines specifically, which means that if you have two slopes and you multiply them together, if the product is -1, then they're perpendicular. So we learned some of these things. We're going to learn one other thing today. You can see it right here, the distance formula. And that's what we're going to be focused on. Now, we're going to use that in the context of deciding if something is a rhombus or a parallelogram. All right. So let's start by looking at quadrilateral properties. Okay, and the property that matters for today is this one right here. But I want to remind you, this is the one we used for midpoint formula. I'll just put midpoint right here. This is the one we are looking at for perpendicular lines. I'll just put PERP for perpendicular. So today we're going to be looking at this property that's, I put a star beside, and this is going to be using the distance formula. All right, so it's really three formulas or three concepts that you need to understand. And we're using it kind of, quadrilaterals is just helping us understand what these formulas and concepts, how they're being used. Okay, so let's introduce the distance formula. And maybe it's an introduction, maybe it's just a refresher, because I feel like you would have seen this in the past, but again, it might have been long enough that none of this makes any sense at this point. But anyways, it's really not that bad. The basic idea is that if we know two coordinates, we can find the distance between them, the straight line distance. And we must use the distance formula to do this. And it does look intimidating, perhaps. It certainly looks more intimidating than anything else we've seen, but it's really, really not that bad. I hope that as we go through a number of examples today, you'll see that we can just go through this step by step, and it's really not so bad. All right, so I just want to jump right into it. I'm going to find the distance between these 2 points. And the first thing I want to say from the beginning is that we are not going to just plug this into the calculator and get a decimal answer. If I plug the numbers in, if I did it all right, it's going to give me some kind of a decimal answer, but that's not what I want. We are going to simplify a radical in the end as much as we can. So we'll see for different problems, sometimes we can simplify, sometimes we can't. So we're already luckily familiar with this notation right here, the x2, x1, y2, y1. And as a reminder, I can pick either one of these points. It does not matter which one, and I'll go into this more. But if I call this one x1, y1, and this is x2, y2, I can plug these in. If I flip these around and called the other one 1 and 2, vice versa, then that would not change my final answer. This is actually a pretty resilient formula, and that it's, as long as you keep things basically right, then you can have a little bit of mixing stuff up and it's not that big of a deal. Now you can't put your y values where your x's are. You can't mix up an x and a y. Anyways, let's just run through this. All right, so my x2 is this value right here. And I'm going to plug that in. So it looks like my first value right here is going to be 4. And then minus, notice that it's always minus inside the parentheses. So I'm going to do minus, what am I subtracting? I'm going to subtract x1. x1 happens to be -2. So I'm going to subtract -2. So even if your second x value happens to be a negative, we're still subtracting it away. I'm going to subtract a negative. And then there's a plus right there. So I'm going to add the next expression. And this is going to be y2, which is 3, minus y1, which is over here. And that's going to be 1. So I'm going to pause right there and see if there are any questions on where those numbers came from. And I might even do this to make it really clear. x1 is -2. y1 is 1. x2 is 4. y2 is 3. And those came from the coordinates. So now I can plug those in. We can see the numbers very clearly now. So I don't just want to plug this into the calculator. That's what I was mentioning before. Instead, what I want to do is I want to look just inside the parentheses to start off with. 4 minus -2. Now, if I'm subtracting a negative, that's the same, and I'm going to change this real quick. That's the same as adding 2. So 4 minus -2 is the same as 4 plus 2. And hopefully you remember that from years past. So 4 plus 2 is just 6 squared. Plus, now 3 minus 1, we know that's just going to be 2 squared. All right, and again, I can, at this point, you might want a calculator, but maybe you feel comfortable with squaring things. Remember, squaring just says take that number and multiply it by itself. So I'm going to do 6 times 6. 6 times 6 is 36. And then for the next one, that's the first one. The second one is going to be 2 squared, which is 2 times 2, which is just 4. All right, and that gets me square root of 40. So all I'm doing is doing a bunch of simple calculations underneath the radical sign. And at this point, I want to simplify the radical. I want to find the biggest perfect square factor. So if I'm looking through, I've got 4, 9, 16, 25, 36. These are my perfect squares. If you remember, that's 2 squared, 3 squared, 4 squared, 5 squared, and 6 squared. So I can see right here that 4 is going to multiply into this. So I'm going to rewrite this as the square root of 4 times the square root of 10. And I know what the square root of 4 is. The square root of 4 happens to be 2. So if you've been keeping up with practicing with your radicals, this is not going to be anything new. So now I've got 2 times the square root of 10, and I don't think 10 can be simplified any further. There's no perfect square factor of 10. And if you want to test it out, you can look at these numbers right here, see if any of those are factors of 10. And none of them are. So anyways, this is my final answer. 2 square root of 10 is the distance. And that's how we'll leave it. All right. I think, okay, the next problem, we're actually going to come back to this one. So I will pause there for a second. Any questions on this? All right. We will have more examples that I go through and do the full process on. So let me first of all take us over to Delta Math, and you can see your homework for tonight. So you're going to have, I think, 4 or 5 of these. I can't remember what I gave you. I think there's 4. And it could look in one of 2 different ways. It could look like this. And if it looks like this, it's actually slightly more challenging. ever so slightly because we need to come up with the coordinates first. So for this one right here, the coordinate is -5, 4. So I'm just going to write that -5, 4. And for this one, it's -1, -5. So this is -1, -5. All right, and now if I just want to call this, I'll just call x1 and y1. Let's see, x1 is going to be -5, y1 is 4. I'm just taking those coordinates right there. X2 and y2 will be -1 and -5. Again, I just took those from right there. So at this point, I can just use my distance formula, and I'll go back and show you this in a second. I have a reference sheet for you that you can use as much as you'd like. You can have it out for your test. And part of the reference sheet includes the distance formula. You do not have to have this thing memorized, and I'll write it up on the screen every single time we use it. So this is my distance formula, and technically it's distance equals this. So if I started plugging in, I'm not going to go through the full math on this one, but I will just plug some numbers in real quick. So x2 is -1 minus x1 is -5 squared plus y2, you can see right here, is -5 minus 4 squared. All right. So at that point, you have the equation set up. You can just kind of run through it. I will do some more examples, like I said, the full thing through. I just wanted to show you your problems could look like this. And what we're finding is the distance right here. So that distance is what we're finding. All right, let me pull up what the problem could also look like. And the other way it could look is actually slightly easier. I will again pause. If there are any questions, feel free to jump in the chat or out loud. All right, let me pull up another type of problem. And there we go. It could look like this also. It's just going to be randomly picked out. So you're going to have 4 of these, and you'll probably get a mix and match to some degree. All right, so if it gives you 2 coordinates, well, you're already good to go. So I will just kind of label this right here. X sub 1 is 7, y sub 1 is 2. So I'm just calling that my first coordinate. And then x sub 2 is -1, y sub 2 is -3. So now I can plug this in. Remember, your distance formula is square root of x sub 2 minus x sub 1 squared plus y sub 2, oops, not plus, minus y sub 1 squared. All right, I will go through the full process on this one. I'm going to substitute the numbers in. You'll see where I draw them from, and you can make that connection. I'm not going to draw straight lines or anything connecting them. All right, so I've got x sub 2 is -1 minus 7 squared plus y sub 2 is -3 minus y sub 1 is 2 squared. All right, if I jump down to the next, then I can evaluate what's inside the parentheses. -1 minus 7 is going to be -8. And then -3 minus 2 is going to be -5. So remember, I'm squaring -5. And if you plug this in your calculator and you just do something like this, -5 squared, it's going to do this first and give you a negative answer. So that's not how we want to approach it. Okay, so instead, I'm going to do -8 times -8. That's how I want to think of it. And I'm actually going to do this without a calculator. -8 times -8, well, I know the negatives cancel out, so it's just 8 times 8, which is 64. Plus -5 times -5, again, negatives cancel. I'm always going to have a positive number when I square something, and 5 times 5 is 25. So now when I add those up, I'm going to get square root of 89. All right, now I need to go through and think if this has a perfect square factor. And I don't think it does. Because remember, we're trying to put this in simplest radical form. So I'm going to simplify this radical. So I know it's not divisible by 4. These are just my perfect squares. I'm going to go down. 9, well, I know 90 is a perfect square. Or sorry, 90 is a factor, a multiple of this. And that's 108. So I mean, I could try it. 89 divided by 9. But that gives me a weird decimal. So no, it's not that. 16, well, no, it wouldn't be 16. It needs to be an odd number, maybe 25. But again, I could get, if I tried to do 89 divided by 25, I get 3.56. So that's not it. The only other one to try is 49 because 36 won't work. It has to be an odd number. So if I try 89 divided by 49, again, I get a weird decimal. So it looks like this is the simplest I can make it. Again, hopefully you've been practicing with your simplifying radicals. So square root of 89, I'll go ahead and submit it, see if this is right. Yes, it is. And luckily it goes through and it explains and it shows you all the steps. So if you made a mistake, you can see that here. And here, this is actually good. I'm glad we're seeing it. I'm going to clear this a little bit. Notice that when they did their math, they switched this around a bit. Notice that they put the 7 minus -1. We did -1 minus 7, but it did not change our answer. All right, so that's why I'm trying to show you. Luckily, you can flip these around in the order and it's okay. All right, let me go ahead and come back to the Canvas page. So that's what your homework will look like. It'll be a mix of 4 of those. On the Canvas page, so this is something worth knowing, and hopefully everyone is paying attention. Yeah, it says in the formula, you always have to make both points squared. So what you're doing is you're getting the difference between the 2 points and then squaring that difference every time. So we'll go through some more examples of it. And I don't know if I answered your question or not, but we're getting the difference first, then squaring whatever that difference is. So there's going to be an example for you here. This will pull up in just a second. So there's the midpoint, and there's an example given. So if you have these 2 points, it shows you how to plug it into your midpoint formula and come up with your midpoint for it. So this is something you can have available while you're doing the test. You do not have to have this formula memorized. This next part is talking about perpendicular lines. If your 2 slopes multiply to -1, then they are perpendicular. All right, here's the distance formula. And you can see right here, the formula is given and it gives you an example so that you can follow along with that. So on the test, you will have something you can refer back to. I just want to make sure that's very clear. So this is found, if I go back, this is found under Unit 3. It's this Unit 3 reference sheet, very first thing. Okay, last little bit. Let me go through what the rest of your homework will look like tonight. And I'll bring this up. So what we have here is potentially a rhombus, potentially a parallelogram. Maybe you can look and determine that right away, but we are going to use what we know with the distance formula in order to determine this mathematically, not just our best guess based on appearances. So any 2 adjacent sides can be used to determine if this is a parallelogram or a rhombus. We will have to use the distance formula twice, but it doesn't matter which 2 sides we pick. I'm going to pick this one. And the other adjacent side, I will go with this one right here. So hopefully you can see the ones I marked in red, the left and the bottom. So I need to come up with these points. So let's see, I'm going to go, A is at -4, 3, and B is at -6, -4. I'm only going to worry about those two. So let me find the distance between those two real quick. x2 minus x1 squared plus y2 minus y1 squared. Plug these numbers in, and we get x2. I'll call this my second, and this will be my first equation. So I'm going to get -6, because that's the x value for that second one right here, minus, sorry, all right, minus, sorry about that delay, -4 squared plus -4 minus 3. So there we go. That's what it looks like when I take my x2 and y2 and then subtract the x1 and y1. All right, again, I'm pausing on purpose in case something is not working for you, you're not getting it, you can jump in, or you can maybe just make a note that you have more questions and we can go through this afterwards. So whenever everyone else leaves, if you want to stick around, maybe we can come back to these problems. So let me just start evaluating this. -6 minus -4. This looks complicated. -6 minus -4. Sometimes it helps to think about this visually. So if here's 0, and I've got -6 down here, minus a -4 is the same as +4. So that means I'm going to move 4 in the positive direction, which takes me up to -2. So if you like to think about it visually, then that's maybe what you can do there. So this is -2 squared plus -4 minus 3 is -7 squared. When I square the negatives just go away. So basically it's just 2 squared. 2 times 2 is 4. 7 times 7 is 49. So I get the square root of 53. And I can look at this and I can pretty quickly figure out this cannot be simplified. 4, 9, 16, 25, 36, those are all different perfect squares, and none of those, I can try them all, but none of them will simplify this down. So I just have to call this, the distance here is square root of 53. All right, so let me not clear everything, but that was the first distance formula we had to do. Here's the next one. All right. So I will also erase this. We don't need this point anymore. So what I'm going to do is I'm going to find the coordinates to C right here. So I already have B. So this is at 1, -2. This will be my new first point. So it's going to be x sub 1, y sub 1, like that. All right. So starting to plug in, it's going to be -6 minus 1 squared plus y sub 2 is -4 minus y sub 1, which is -2. All right, so -6 minus 1 is just going to be -7. -4 minus -2, same thing as before. When I have -4 essentially +2, then that is kind of moving it to the right, so I get -2 as my answer. -7 squared makes it +49. -2 squared makes it +4, so this is 53. So the distance for this one is also square root of 53. And now here's the idea. If these two adjacent sides are congruent, same length, then this is a rhombus. So they are, and we never need to worry about if it's a parallelogram or not. These are going to be at least parallelograms. The question is it a parallelogram or a rhombus? And this one happens to be a rhombus. And I will pause there again. Are there any questions on this one? All right. So let's go ahead, raise our hands so we know that we're all paying attention. All right, so we've got one more problem to look through. Same thing as before. You might look at this and determine it's a parallelogram or rhombus, but that's not good enough. We're going to do it mathematically. And it is at least a parallelogram, but we want to determine if it's a rhombus. I'm going to use distance formula. I'm going to pick any two adjacent sides, and I'm going to go with this side and this side. So as long as there are two sides next to each other, you're good to go. All right, so let's go ahead. Let's do this left side first. This point A we're going to use for both. I'll call it point 2. This is going to be at -4, 5. So that'll be x sub 2 and y sub 2. And for B, it's going to be at, this will be point 1, and that'll be -3, -2. And that'll be x sub 1, y sub 1. The distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So now I can plug numbers in. X sub 2 is -4 minus x sub 1 is -3. Square that. Plus y sub 2, and if you're, maybe I should stop and pause. I've done this a lot, but I just still want to make sure I'm not going too fast. Y sub 2, notice I already labeled it right here. Y sub 2 is going to be that 5. Minus y sub 1 right here is -2 squared. So now I get square root of, let's see, -4 minus -3. Well, that's -4 plus 3, which is -1. Plus 5 minus -2, that's the same as 5 plus 2, which is 7. So at this point, I've got square root, -1 times -1 is +1. 7 times 7 is 49. And that gives me a square root of 50. Now this is one, I'm going to go through it a little bit fast because this is not a new skill with simplifying radicals. But if you have been practicing and you're comfortable with this, you might already recognize, you know what? I know what that can multiply into, or how I can separate the factors here. That's the same as 25 times 2. And I know that the square root of 25 is 5. So 5 square root of 2. So here's the distance for this. If the next one, just a second. Okay, square root of 2. There it is. If the next one's 5 square root of 2, it's a rhombus. If it's anything else, it is not a rhombus. It's just a regular parallelogram. So let me clear this stuff. Just take me a second. All right, I'm also going to clear this because I don't care about those numbers anymore. And I'm going to have a new point over here I'll call number 1, which is going to be a D, which is 4, 4. And that's going to be x sub 1, y sub 1. So start the process all over again. But it'll get faster and faster each time. X sub 2 is -4. It's right here. X sub 1 is -4 right here. So, it's -4, which is 4 is the x sub 1. So y sub 2 is 5. It's right there. Minus, what's y sub 1? It's 4. And that's squared. So anyways, we get -4 minus 4 is going to be -8 squared, plus 5 minus 4 is 1 squared, So negative 8 squared, the negatives cancel out, so it's just 8 times 8, which is 64, plus 1 times 1 is 1. So I get the square root of 65. And if we're trying to simplify this, I can tell you right now, 65 cannot be simplified. We could try some different numbers. I know this can divide into square root of 5 times the square root of 13, but that doesn't really help us because neither of those are perfect squares. So I'll just forget about that and we'll just leave it this way. So the distance for this is the square root of 65. So these are not the same length. Therefore, this is not a rhombus, it is a parallelogram. Okay, that's essentially it. Let me show you real quick. I'll clear this off. If you need to see more examples, stick around, but I just wanted to show you last thing. You have 2 parts to your homework tonight. One of them is the distance formula that I showed you on Delta Math. The other is a PDF in Canvas. I will take you over there real quick so that you can see what that looks like. It's this one right here under today's date. And there are 4 problems on this. All right, 1, 2, 3, 4. There are 4 problems. You just need to do problems 2 and 4. All right, that's basically it. If you have questions, certainly don't leave until you get that resolved. But if you have any questions, stick around. If you are good to go, have a wonderful day, and I will see you tomorrow.